Hey team, Andre from High Performance Academy here. Welcome along to another one of our webinars. Today we're going to be delving into a topic that I know a lot of enthusiasts really struggle with, and it's a really powerful technique of getting all of your aftermarket and factory electronics to play nice if you know what you're doing with it. This is the subject of setting up CAN communications. Today we're going to be pretty narrow focused. We're going to be talking about the communications between an ECU, a dash, and a power management unit. But essentially, if you understand how CAN works, really you can apply this to just about any aftermarket devices. One of the nice aspects with dealing with CAN devices is it doesn't lock you down into using one manufacturer's components. Because all of the components working that are transmitting and receiving messages on a CAN bus work on a standardized protocol, we can mix and match. So today we're going to be talking about using Motec product combined with Link product, ECU Master product, and some Izzy Racing product in there, just to name a few. Actually, I think I've got a Haltech product in the mix as well. So we'll just show you how some of that works. Before we do dive into that though, we've only got a small window of time left, but if we jump across to my laptop screen, we are still running our Fueltech FT550 giveaway. Sorry, I don't have the real item here in front of me, but we are giving away one of these ECUs. Very powerful ECU. Fueltech have been making some pretty big waves, namely in the drag racing market over the last few years, but certainly not just restricted to drag racing. One of the nice features with the Fueltech ECU is that it's actually an ECU, a dash display, and a logger built into one. So you do get a nice dash display. You don't have to buy a separate display. This is also touch screen, meaning that while no, you're probably not going to program your entire ECU from the touchscreen display, if you do want to make small adjustments to things like your launch control or maybe your boost settings, you can actually do that without needing to dive back to the pits and grab your laptop. So that FT550 along with our suite of tuning courses is going. I think we've got about 27 hours left for that giveaway to run. In fact, we can check and we have got 28 hours left, so I lied. But either way, you're going to have to move quickly. $3,000 worth of giveaway. Doesn't matter whereabouts in the world you are watching from, we will ship directly to your door completely free of charge. I'll get Scott to drop a link into the chat that you can follow if you want to get your name into that draw. I think there's a few other little tasks that you can complete to give yourself more entries, so jump on that. Last day left to run. All right, I just want to change tack a little bit and talk about another project that we have been involved with for probably around about the last 6 to 12 months. And for our VIP members, you'd already be aware of this. But HPA, back at our very early days, we partnered with Nigel Petrie from Engineered to Slide over in Australia. We actually flew over and built a wiring harness for his tube frame Toyota Hilux drift truck powered by a Nissan SR20 DET. It's a build that had a huge following, and we're really stoked to be involved with that. We did the wiring harness, and then while I was in Australia, we ended up tuning it. Now, our relationship with Nigel has gone from strength to strength over the years, and because he is such a talented fabricator, we have partnered on a sister project to High Performance Academy, which is called ETS Fabrication School, or ETS Online Fabrication School, ETS standing for Engineered to Slide. So I've already got a couple of courses out which I will take you through very shortly, but before I do that, I'm really excited about this latest course that we are in the final stages of. So I'll jump across to my laptop screen. This is from Nigel's personal Instagram. Go give him a follow, as well as ETS Fab. Check out HPA 101 while you're there as well. So this is his Nissan S15. It's going to be built up for drifting and a bit of time attack, but as you can see, he's constructed what is a fairly elaborate roll cage to go into this. Now, obviously, no one really wants to end up testing a roll cage, but no matter how careful you are, sometimes accidents do happen, and you do want to know that you are protected. So Nigel, with this build, actually went to the trouble of having the roll cage designed in CAD. This gave him the ability to actually also do a finite element stress analysis on the cage. essentially applying forces that we may see in an accident and seeing exactly how well that roll cage has stood up. This particular cage is a chromoly cage, and it is, as you can see, all TIG welded. Now, this is something that I know a lot of fabrication enthusiasts, maybe just getting started, want to learn how to build their own roll cages, and we're expecting to have that course out early next month, so early in April. So that's going to be awesome for anyone who wants to learn about roll cage construction. However, we'll just jump across to the ETS Fab website, which you can find at etsfab.com. At the moment, Nigel's already got a suite of courses in there, starting with one that I know a lot of people will get a lot of benefit out of, which is the Motorsport Fabrication Fundamentals course. This teaches you some of those core skills that you're going to need to master if you want to learn how to fabricate components on your car, modify existing components on the car. Moving on from that, we also have the practical TIG welding. We'll teach you all the tricks and tips getting the best possible results with the technique of TIG welding. In particular, Nigel gets pretty deep into this as well, covering some of the aspects such as welding, some materials such as stainless steel and titanium, which are a little bit more reactive than the likes of aluminium. The aluminium welding technique as well is covered in detail, because this is something, and I know from experience, I'm no pro welder, but getting a nice stacked diamond finished weld on a piece of aluminium is pretty tricky. It's something that does take a lot of time, but a lot of this also does come down to the settings. So Nigel covers off how to set up your machine in order to fast track your learning with TIG welding. Of course, MIG welding as well, another very popular technique, a little bit quicker, actually significantly quicker than TIG welding, and it's still an absolutely perfectly viable technique for a lot of our motorsport fabrication. So for anyone who is interested in maybe expanding their knowledge beyond the engine tuning, engine building and wiring that we cover under High Performance Academy, check out etsfab.com. It is our sister company, so it's going to have a very similar look and feel to High Performance Academy. Nigel is producing Gold Members webinars, just like what you're watching now for High Performance Academy as well, covering a range of specific aspects. So we'll just actually head over to the webinars page for a moment. This week he is covering gas purging, which is a technique that's really important if you want to get the best possible results, as well as maintain strength on components such as stainless steel exhaust systems and headers. I've already got a number of webinars in their archive. Obviously, it's a new venture here, so I've only got 6 of them at the moment, but that's going to be added to pretty well every week, so there's going to be a lot more information in there. Nigel's also got a forum, just like High Performance Academy as well, so if you've got fabrication questions and you are a member on ETS Fab, then go and ask your questions there. I just wanted to cover our SR86, bit of an update. That is back up and running, so pretty stoked on that. It has been a fairly long time coming, I'm happy to admit, but we will be back on the dyno, hopefully at this stage on Thursday afternoon. Part of this will be getting some data and filming a worked example for our upcoming cam tuning course. The SR20 VVL cylinder head actually gives us a couple of options that we're going to be adding data to in that course. It uses a switched cam system. For all intents and purposes, it's Nissan's take on Honda's VTEC with 3 cam lobes per cylinder, and we can switch that using hydraulic pressure from the oil at a given RPM. So we'll be showing how to set that up, and it's definitely not rocket science, but I still know a lot of people do struggle with the correct way of setting a VTEC style operating system up. We'll also cover off the process of degreeing or dialing in vernier adjustable cam gears on the dyno, and a lot of people don't bother with this. A lot of people will fit them on 0, and at which point I'm not really too sure why they spent the money on vernier adjustable cam gears. Alternatively, you could spend the time degreeing them into the manufacturer's specification card for the cam you're running, but there can still be benefits in actually adjusting the cam timing, advancing or retarding, and seeing whether you can get a power and torque curve that's more suited to your particular application. So we're going to go through that. In particular, for those who have been following the project since the last time it was on the dyno, we have swapped to a set of stock Nissan P12 cams. Now we're expecting that is going to hurt our power quite significantly, but what we wanted to do is bring the RPM range that we're operating the engine in back down to about 7, maybe 7,500 RPM. And for those who have been following, again, you may remember we were making peak power up around 9,000 RPM, and I don't really want to be revving an endurance engine to 9,000 on every shift. So if we can move everything across to the left, sacrifice a little bit of power, which is absolutely fine. We've still got a lot of boost pressure potential up our sleeve to add that power back in, but basically it's just getting a usable power band that's going to give us good reliability, hopefully. Now, as part of that, we are also adding in a sensor that we didn't have time to fit last time, which is the exhaust manifold back pressure sensor. Getting this data can be a little bit tricky, so we'll just jump across to my laptop screen. Obviously, the exhaust manifold and turbocharger is a fairly nasty place to try and fit a sensor. So this is the collector of a turbocharger. Obviously, this isn't our SR86. This is just a car that I shot a picture of over at World Time Attack. But what we can see here is we've got the sensor, which is mounted remotely from the turbocharger. Still going to be getting pretty hot there, but the actual pipe that is taking the pressure signal from the collector, you can see that's a length of stainless tube that has been bent into a bit of a coil. So the idea here is that we want to get rid of that heat out of the system. Now, there's a couple of other aspects there. This one is actually mounted directly to the sensor. Nothing specifically wrong with that, but what you will find is that you get quite a noisy signal from the exhaust back pressure sensor. Obviously, you're basically seeing pressure spikes every time the exhaust valve opens and closes, which can make the data a little bit hard to do much with, particularly if you want to incorporate it as a load signal. Perhaps you're looking at running inlet manifold pressure divided by exhaust manifold pressure or engine pressure ratio as your load axis for your fuel table. That's going to be hard if you don't have a nice clean signal. There are a few ways of doing this, but the technique that we're using is to use a mechanical damper, which is this little guy here. Let's just get that under our overhead camera. There's not a lot to see. If you're wondering, this one is from Tony Palo at T1 Race, and essentially it's just a canister. I haven't cut this open, but I believe it is tightly packed with stainless steel wool, and we've also got a really small hole at the top where the sensor is going to go. Basically, it's just an expansion chamber and allows the pressure spikes to be removed out of the system. So we fit the pressure sensor at one end, and we fit the feed from our exhaust manifold in the other. Speaking of that, Jimmy, in-house fabricator, has just got started on replicating what you saw in that little Instagram photo before. So this is 3/16 diameter stainless steel tubing, and basically he's just bent this up into a bit of a coil. Just allows a little bit more surface area, a little bit more length in this to get rid of that heat before it makes its way through to that canister. So why do we want exhaust manifold back pressure? Well, as I've mentioned, one option is that you can actually incorporate this as part of your load axis, but we're not doing that in the case of our SR86. It's a case of having some more data to help us with our turbo sizing. So by looking at the relationship in particular between inlet manifold pressure and exhaust back pressure, this will give us quite a good guide to how well matched the turbocharger is for our application. It's a case of there are no free lunches here though. Basically, the bigger the turbine wheel and turbine housing, the lower your exhaust manifold back pressure is going to be, which means that the exhaust side of the engine is going to be much freer flowing, less restriction, easy to get that exhaust gas out, which is great. Downside with this is that as we go to a larger exhaust wheel and larger exhaust housing, this also reduces the amount of drive energy available to actually drive the turbine wheel. So as we move to larger turbine wheels and housings, we end up with a increase in our high RPM boost, high RPM power, not boost. We generally will end up sacrificing our boost response, or whereabouts in the rev range the turbocharger actually makes usable boost. So it's all a bit of a balancing act there. What would be perfect for a drag car that's only going to be operating between, let's say, 7 and 10,000 RPM at full throttle would be absolutely terrible on the street. A case in point, my own drag car, we weren't actually making full boost until 7,000 RPM. So up until that point, it probably probably would have been slower than a factory showroom stock Mitsubishi Evo 3. So you do need to factor that in. It's all about making compromises and deciding on the compromise that you are comfortable with. And now I do want to also remind you, if I can find the correct page here somewhere. I can't find it. Maybe I didn't load it up. That's all right though. We are running a podcast now, and hopefully I can get Scott to drop a link that you can follow into the comments to find it, the page that I should have loaded up, but that is hpatechtalk.com. So the podcast that we're running is going to, at the moment, we've been up and running for a few months, and Luke's been mastering that here. He's basically been taking some of our existing interviews, our YouTube releases, and turning those into podcasts. It's another great way to consume some technical information that you don't actually have to physically sit down and watch. So personally, I love listening to podcasts while I'm going for a run or working out. A great way to consume some content there. So if you are into podcasts, you'll find HPA Tech Talk at all of the usual places that you may listen to podcasts. In the time to come, we will be adding additional content specifically for our podcast as well. I also wanted to mention the latest, or one of our latest YouTube releases. We'll head across to my laptop screen, and this is one that we shot a while back when we were at PRI. It's a tech talk with the guys from Total Seal Rings. So gapless rings are something that we hear a lot of people talk about, but there is a lot of confusion, a lot of misinformation about what a Total Seal ring is, how it works, and what the advantages and disadvantages of that technology are. So we get really down in the weeds with Keith from Total Seal about what makes Total Seal rings tick. And if you are interested in what a Total Seal ring is, or a gapless ring, Total Seal make gapless and conventional rings, but I do have a Total Seal gapless ring here. It's probably going to be a little bit hard for me to show in detail, but let's go to our overhead and I will do my best. So the Total Seal type gapless style ring is a two-piece ring, and it isn't actually gapless. As you can see, we do have a gap for both parts of the ring. This little one here does look suspiciously like an oil ring rail. I can assure you it is not, and it is really important when you are dealing with a gapless ring to make sure that the second part of the gapless ring is kept away from your oil ring rails so that they do not get mixed up. Now again, a little bit difficult for me to really show you, but there is actually a step on this ring. So it's actually sort of like a little L shape, and when we assemble this, basically we'll already have it on the piston, and we assemble it with the gaps 180 degrees opposed, and this probably won't play the game for me because now we're running a live webinar, but you can get that to, no, it's not going to work. You can get that to sit nicely on that little step. This works a lot easier when you actually have the ring on the piston. So basically what you've then got is a two-piece ring. Because the gaps are 180 degrees opposed, it doesn't really give any path for the combustion gas to get past the ring, as we'd see with a conventional ring. So the result of this is we'll see quite a lot lower leak down. If we do a leak down test on the gapless ring, it'll be lower. Oil consumption generally lower, and we can see a small improvement in power. So if you are interested in learning a little bit more about gapless rings, what makes them tick, and whether or not you should be considering them, check out our YouTube channel. If you've got questions, please ask them there. We do our best to reply to all of them, and while you're there, make sure you subscribe, and if you like that video, give us a thumbs up. Makes us feel a little bit better about what we're doing. Right, lastly for today, I just wanted to also mention an Instagram that I put up over the weekend. So this is an older car. This is actually a Nissan Group C race car. So technology's moved on a little bit, but it's still a good representation of some of the considerations around getting reliability in the hot side of a turbocharged engine. So what we end up with in turbocharged engines, obviously a huge amount of heat being generated. The exhaust housing, turbo manifold is all going to be glowing bright red when we're out on the racetrack. So everything expands, obviously, as it gets hot. This, however, does result in problems with cracking with all of those components if we don't deal with it correctly. And this then sort of shows a bit of a masterclass here on how to deal with this. First of all, we've got this black brace that I'm just highlighting here. So this actually goes back to the chassis. There's a third leg here that comes down, so it's nice and rigid. And what this does is it provides a nice solid mounting point or bracing point for the turbo. And what we want to do here is support the weight of the turbocharger. Obviously, the turbocharger is a significant amount of weight, and if we just let it do its own thing, it's going to be bouncing around there as the car goes around the track, going over curbs, and that weight is all needing to be supported by that massively glowing hot exhaust manifold. So it's not great. Instead, what we've got here is this little link that runs from that brace down to the turbocharger exhaust housing, or center core, I think it is. And what this does is supports the weight of the turbocharger, but because that little brace there, that little link uses rod ends at both ends, that actually still allows a little bit of movement as the turbocharger and the exhaust manifold heat up and cool down. And that's the essential part. If we actually just physically hard mounted the turbocharger, that's going to absolutely result in cracking because it doesn't allow that expansion and contraction that we're naturally going to get. Now, another aspect that we can see here is that both the wastegate dump pipe as well as the turbo dump pipe, they both are not actually welded directly to those flanges. Instead, they use a double slip joint. It's a little hard to see the details there, but the double slip joint just essentially slips over the outlet from the wastegate and the turbocharger. It still seals the exhaust gas, so we're not going to end up with exhaust gas leaks, but it allows everything to move around a little bit. And then you can see that springs are used to actually retain those components. So considerations like this, as well as properly supporting the weight of the exhaust system and the wastegate dump pipe, are really important to improving the life expectancy of your turbo hot side components. Right, we'll just finish up by reminding you once again that we do have that FuelTech FT550 giveaway plus our online tuning courses. 28 hours left, probably 27 by the time we've got around to this point in the webinar. Make sure you get your name into the draw. We'll ship it to your door. Absolutely no risk and no cost getting involved. So again, head along to the link in the chat and you can get your name into the draw. All right, thanks for watching there, guys. Give me a few moments and we'll get started with today's webinar.
If you like that video, make sure you give it a thumbs up. And if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.